All right, depending on how today goes, we might do a variety of things. And we can go off in two directions. I'll wait a bit before we do our exercise. And I meant to upload videos again over the weekend, but I never got the chance to do that. The big thing that we did not do is, that I meant to do over the weekend, was to go over while loops. Okay? So the last type of loop that you guys need to know about, which is a while loop. So let's go ahead and just go over that, and then we can go over the practice exam. Or I might do an exercise before we go over the practice exam, because we'll see where we are. So let's go over while example. Okay. So one of the things that we need to, so actually there's a lot of little things that just need to be gone over today with regards to strings and while loops. Folks, that void main. Let's see. So so we've learned about for loops, right? For int I is equal to 0, I is less than, if we put in some number over here, like 100, this loop will run 100 times. So if I run this code, system.out.print line, hello, this program will print out hello 100 times. Assuming I actually run the code I said I was going to go. There we go. So this prints out, right, basic loop there. Print out 100 times. Now, we call this type of loop a definitive loop because we know definitively how many times it's going to run, right? That's kind of the structure for this. It's going to run until we print out the word hello. On the other hand, there are sometimes things that we don't know how long they're going to run. And that's what a while loop is used for. Okay? What we call an indefinite loop. Okay? So, first, I'll show you what a while loop looks like in the form of a for loop, because honestly, a programming language only needs a for loop, or you can use a while loop. You don't need both, but it's nice having both. Okay, it's really nice having both. So let's see what this looks like with a while loop. Now, while loops are look a lot like if statements, in the sense that they have a while and then this, right? So an if statement says, if this is true, do this. A while statement says, while this is true, let's do this. Okay? So while this is true. So while, so let's suppose we have some int I is equal to 0, while I is less than 100, right? So while 100, so obviously this code block is going to run, okay? In fact, it will run forever if I just keep doing this because I never changes. So if I do sout hello, this will run actually infinitely because, right, we never change i's value over here. I plus plus. So while I is equal to 0, I is less than 100, print out hello, I plus plus. So this prints out I 100 times. Now, mind you, a for loop's a lot of times easier to use here because with a for loop, it's more constructive. But you can see that this is the same code that I wrote for a for loop earlier. What this is better used for is something along the lines of figuring out, like, basically waiting for a user to enter something, or taking in user input and checking if that's okay. Like, let's see. So let's try this out. So let's say we want to take in some user input. String input equals something, right? And let's say we want them to enter a word more than 10 letters, okay? Okay, string input is equal to blank, okay? String, let's see, string input is equal to blank. Then we need a scanner to take stuff in. So scanner is equal to scanner is equal to new scanner system.in. Okay? So we've got a scanner, we've got our input thing, right? So we've got our scanner, we've got our input, and what we can do is that we can ask the user to enter something. So let's say while input, and I'm going to do something incorrect here for a minute. While input is not dot length, actually it's not wrong here. I'll get into that later. So ignore what I said. While input dot length is less than 10, right? We want them to enter something of 10 characters or more. System.println, please enter a word 10 that is 10 characters or longer. Okay? Please enter a word that is 10 characters or longer. Right? Scanner is equal to, okay, and now what are we going to do? We are going to take in our user input from the scanner. Next line, right? And then when we're done, we'll print out the word. Input plus is plus input dot length plus characters long, right? It's a very short program here. What it's going to do is that please enter a word that's 10 characters or long. So I'll put in my name, Andrew, and it tells me please input a word that is 10 characters or longer. So I'll put in, how are you today? How are you today is 18 characters long, right? So a while loop continues going on until this if statement, until this Boolean statement over here is false. So long as it's true, we'll repeat the loop. Now, obviously this means we want this to become false at some point. It is possible that sometimes we want this to be true. Now it's possible that we can set up conditions, of course, that a while loop might not run, but that's fine. Just like an if statement sometimes doesn't run. But so long as it's true, the while statement will run. Okay, so system.println input is input.length characters long. Okay? So while loops are kind of simple like that. Let's see. Yep, so I'm sorry, let me just pull up the... So you can read more about while loops in chapter 7. Right? Here's a method they use for that, and let's take a look at it. All right. So let me paste in this method. Public static void countdown. While it takes in an integer n. While n is greater than 10, while n is greater than 0, print it out, and n is equal to n minus 1, which we can, of course, rewrite as n minus minus. In other words, decrement n by 1, right? So public static void main, we already have that in here. So now we can look at, let me comment this piece out. Right? I'm always very careful to make sure my curly braces are fine. So now let's call countdown. Countdown, if I put in 10, it'll print out 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Why? Because it takes in 10, or rather, remember, it takes in a copy of 10. It decrements it to 9, then 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1, then 0. And once it's hit 0, 0 is not greater than 0, so the while loop terminates. So we can add a sout blast off onto the end. So once we get n to 0, This is a false statement, so it terminates. Okay? So it's fairly straightforward. You evaluate the condition. It's either true or false. If it's false, we skip the body. If it's true, we execute the body and go back to the top of the while statement. Okay? Now this is a fun bit of math over here. Actually, I recognize this. And what we call it an indeterminate loop because it's even when it involves math, it's sometimes hard to know how long something runs for. So we're going to learn just a little interesting bit of math here. Something called the Collatz sequence. So let's go ahead and see. So the Collatz sequence is actually this really fun bit of math. All right, and it says it's basically two mathematical rules. You don't really need to know. It's an unsolved problem in mathematics, even though it's so simple to understand. Okay? It's really simple to understand. But sometimes the simple things are really the most difficult thing. So it says that the Collatz sequence is as follows. Essentially, if you're given an even number, right? So if you're given n, we generate either one of two things as the next item in the sequence. So if you're given n as a number in the sequence, the next number in the sequence is n divided by 2 if n is even. Otherwise, it is 3n plus 1. Now, this is a wonderfully simple rule. It's actually not that hard to generate numbers like this. So, and the sequence terminates at 1 is kind of the last rule is that if you get to 1, we just stop. Okay, if we get to 1, we just stop. Okay, so 2 just leads us to 1, right? And if we did a number like, let's go with 5. 5 is an odd number, right? So what's the next number in the sequence? It's 3n plus 1, so that would be 16, right? Which you divide by 2, you get 8, which you divide by 2, you get 4. You get 2 from that, and then you get 1. That's not too hard to understand because these are just powers of 2. So the Collatz conjecture, which is an unsolved problem in mathematics, completely unsolved, which is, does it actually always end with 1? We just assume that it's going to end that all these sequences end with 1. And we've tested it for every integer in the sense that every 32-bit integer, right? We've tested this for a billion numbers, and it works for all those. But we have yet to mathematically prove that this rule always ends with 1, right? We don't know actually when this ends. So this is actually a great example of using an indeterminate loop to solve something because we don't. If you wanted to generate the sequence, we don't know when it would end, right? With a for loop, you can tell when this ends. With this Collatz sequence, you don't know when it's going to end, right? Let's draw, like here, I've generated some numbers, right? 1, you know that 2 goes to 1, right? 3, well, 3 will go to, what's the next? It's 3n, right? Plus 1, so that goes to 10. Okay, and 10 is even, so that goes to 5, right? And we learned earlier that 5 goes to 16 because that's 3n plus 1 to 4, right? Which goes to, this goes to 8 to 4 to 2, right? And it just builds up as this graph kind of deal. But it's a perfect example of an indeterminate loop. So let's look at how it's coded up in our code, in our book. Right, and it's got a very simple sequence. But this is a great example of an indeterminate loop, even when we're using a number. Right, this will generate this Collatz sequence of for any given number that I give it. So n is not equal to 1. So while n is not equal to 1, print out n. If n is even, divide it by 2. Otherwise, if n is odd, n is n times 3 plus 1. So let's go with So let's just go and check our answer, it against the answer I did on the board. So Collatz sequence of 5, right? Collatz sequence will give you 5, 16, 8, 4, 2, and then it terminated at 1, right? So let's go ahead and throw in another random number to check it. Like maybe 567. Let's see how that goes. So 567, then multiply by 33, add 1, divide by 2, multiply by 3, add 1, divide by 2, multiply by 3, and add 1, divide by 2, divide by 2, right? And it just keeps basically, it keeps oscillating back and eventually makes its way down to 1. Eventually it hits 5, right? Rather, it hits 10, which we know goes to 5, which we know goes to the power of 2 sequence, which is interesting. Again, completely unsolved problem in mathematics. I think the standing value of it is that I think Paul Erdos offered $100 for the successful completion of this problem because I think he was very frustrated with it.
Complete this problem yet?
No, nobody has proved. It is called the Collatz conjecture, and it is an unsolved problem in mathematics. Nope, he offered $500 for its solution. Extraordinarily difficult problem, completely outside the reach of present-day mathematics. Doesn't seem like it would be, but it's a really hard problem. But we assume that this is going to work. So let's see. So your book goes over a lot of statements for these. Here's a let's see. Why don't we go through this? So two tables are one really good way of generating data. So before you had computers to solve these things, a lot of things we would have to do, you'd have to calculate sines, cosines, and logarithms by hand, which sucked. So rather than doing that, of course, you had books of just that were lists of logarithms and cosines and sines that you would look up. Mind you, when we can, so when people assumed that once computers came out, actual computers like machines, they assumed, the machine could never be wrong. And they were wrong about the machine never being wrong because of our floating point error, which I've showed in Python, but I don't think I've showed in this class, right? So this was a problem that affected the early, the Pentiums. It was a bit nasty, but anyway, what it would do here, I'll just go ahead and show you an example, which I've shown. Sout 0.1 plus 0.2. I've shown this in Python. I don't think I've shown this in here. Now the answer should be 0.3, but we end up with 0.34. Now why does it end up with this? And by the way, people had to look very hard to find this as an error. It has to do with converting decimal to binary, because remember these floating point numbers are stored in binary. But to tell you a reason why this occurs, this is the same. It occurs for the same reason that when you do 1.0 divided by 3.0, right? You get a bunch of 3s, right? Or when you do 2.0, you get a bunch of 6s, right? It's because that the number system we're using can't fully encapsulate this 1/6 or a third or 2/3. So let's see. All right. What I want to get into is the let's see. So we've got our loops. And what we've got over here is a so anyway, that's a while loop. We've been working with loops for a while, and it's useful to be able to do while loops as well. But we're typically going to use it for user input. So I want to work on something on what I typically assign as homework. But instead I want to give it out as its own little thing. I typically assign this with the blame the Pope problem, but I wanted to do it as its own in-class exercise this time around. So, and I call this one blame Latin because it went with the, with Pig Latin. It's a fairly good assignment, and I'll put it up on the web after I go over it with it. But it's something we'll do together, which is this one will use while loops. So this one's called Ingstray Manipulation A. Okay. Now, how many of you have heard of Pig Latin? Right? The Americans have heard of Pig Latin, and maybe not all of them, but it's because it's something that it's a game kids would play, and by game I mean thing that kids would do to be annoying, which qualifies as a game when you're 10. Okay, so Pig Latin is a fake language. Okay, and we're going to be using very simplified rules for Pig Latin. But the object of this is to create a Pig Latin translator. Right? Pig Latin is a made-up language, and we're going to translate to Pig Latin. So we're going to write a program that allows you to input words, and it will transform them into Pig Latin. Okay? And the way Pig Latin works is by basically moving. If it begins with a consonant, we move the consonant to the end, and we add a. So pig becomes igpay. Right? Everybody see how pig becomes igpay? Latin becomes atenle, okay? Banana becomes ananabe. Duck becomes ukde, right? So we just take the first letter, move it to the end, and add ay to it, okay? If it begins with a bunch of consonants, like cheers, we take the whole group of consonants. In other words, these two rules can be condensed into saying we take everything before the first vowel and move it to the end of the word. So cheers becomes earshay. Smile becomes islesmay. String becomes ingstray. Right. So we're taking everything before the first vowel and moving it to the end of the word, and then we're adding a to the end of it. Ay. Okay. Then we're going to just use the simplified version, which is we're just going to add way to the end. So that for things that don't begin with vowels. If it doesn't begin with vowels, we just take the first couple. We take everything before the first vowel and add it to the end, and then add a to the end of it. Everybody, that makes sense for everybody? For words that begin with vowels, we are going to take. Let's see. Yeah, alternate is to use, yes. So I use the alternate rule, which is that if it begins with the vowel, then we take the vowel and move it to the end and add way to it. Okay? So if we take alakazam, that will take the a to the end, and it becomes lakazamwe. So for everything with a vowel, we just take all the stuff before the first vowel, move it to the end, and then add ay to it. If it begins with a vowel, instead we take the vowel, move it to the end, and add way to it, even if it becomes gibberish. Okay? So this is example input-output that from my working code. So I put in letter, it became ederle. I put in foo, it became ufe. I put in bar, it became arbe. Right? See how now everything's working in turn. So the idea here is that the program repeats this, e.g. with a while loop, because we're going to keep doing this until the user types in done. Once they type in done, they are done with the program. The program terminates. Right? So notice how when I typed in done, it didn't go unday. Right? It just stopped. So when I start typing in, so how do I transform into the Pig Latin? So this seems like it's a simple to understand program, the objective, but how do you organize it, right? So the first thing is that I want you to make a class. We're going to call it string manipulation. So let's start by going into your IDE right now and making a class, okay? So we're going to go into our class, into our code, and hit new, and create a class, and we're going to call it string manipulation, because I want to start this one with you so you guys get it off on the right foot here.
Wait, file what?
Just whatever you're using to create a new project, right?
Alright.
And you're going to create a class called string manipulation.
A project or a class?
Either or. I mean, so, right? And what I'm going to go over is I'm going to go over the various pieces of this. Each piece of this program is going to be an individual method, right? And once you solve that, and you can solve each of these methods independently one another. Think of them as each of a little puzzle. And when you combine all the pieces of the puzzle, you get something working. Okay? So all your methods are going to be static, which is what we've been doing so far. So we're going to go over 3 methods. First is the main method, public static void main string args, right? So what that's going to do is that's going to run a loop. What this is going to do, it's going to run the loop. It's going to ask the user to input a word. It will convert the input to lowercase. And then it will print the input, converted to Pig Latin, and the input reversed. Which I don't think I put in there, right? I'll remove that bit. Just convert it to Pig Latin. If the input is done, then we stop the loop and it ends. So this is basically going to do a lot of the work for us. So let's look at the other methods I defined. Find first val. That takes in a string and it returns an integer. The returned int is the location of the first val in the string, right? Remember the count vowels program, mini program we wrote? This might be a bit useful for that. If there's no val, we're going to return -1. Why -1? Because in Java, -1 is what we use to indicate that it's not in something, that something's not in something. So this is essential for us to help to work on Pig Latin. Why? Because everything in Pig Latin depends on where the first vowel is in the word we're converting, right? If the first vowel is at the first letter, then we transform it one way. If the first vowel is in the middle of the letter, we transform it another way using substring operations, right? So convert to Pig Latin, that's just going to be a method that, given a string, returns a string, and this return string is going to be the Pig Latin form of the input word. A word is converted into Pig Latin by one of the 2 mutually exclusive words. In other words, it's got to be one or the other. If it starts with a vowel, move the vowel to the end of the word and add way to the end of the word. Otherwise, move all the letters before the first vowel to the end of the word, and additionally add a to the end of the word. If there's no vowel in it, just return the word, right? If there's no vowel, just return the word unchanged. Because, so now think about how we can use find first vowel. First vowel returns the index of the first vowel in the string, right? So there's 2 rules, if it begins with a vowel or doesn't begin with a vowel. What will find first vowel return if it begins with a vowel? It's gonna it returns the location, not what the vowel is. It's gonna return 0 if it begins with a vowel, and it's gonna return something else if it doesn't begin with a vowel. So we can use find first vowel, and if find first vowel returns 0, then it starts with the vowel, right? So let's go ahead and start by coding these up. So follow along with me. So we're going to go with public static int find first val int, sorry, not int, string word. So we want to find the first vowel of this word. For right now, we're just going to return -1 because we're going to leave it to fill out later, right? This is a to do, right? I'm going to put actually in big caps right over here, to do, right? We still have to do this. Another to do, we're going to fill it out. We're just listing everything here first. So to do, public static string convert to Pig Latin, right? Word, string word, okay? Return word, right? We're not finishing these yet. What instead we're gonna do is we're gonna build our program from the top down. And what we're going to do is that we're going to assume that when we're going to write main right now. And what we're going to do with main is that we are going to assume that everything works to convert to Pig Latin, even though all it's going to do is not going to transform it. But then we can change then we can fix it so it transforms it, and then it will magically all work all at once. But we're going to work on it piece at a time. So the other thing, I have more other things. So important, the instructions specify the program ends when the user enters the string done. This means you'll be storing the user input in a string named something like input and comparing it to a string, the string done, to check if they're equal. However, strings are objects. And this means if you try to check them using double equals, you might not get the result you expect. It might return false when you do true. A string.
Convert string.
Yep. Public static string, convert to Pig Latin, string word, right? Takes in a string and it returns a string. Now, this is because double equals, when we use double equals, it stores the values stored in the variables, right? And I mentioned that primitives, it just stores the value, right? An int's 4 bytes, an a double is 8 bytes. But objects, they don't have like strings, they don't have set sizes. So instead, what you do is that what it does for strings is that it creates a variable. Sorry, what it does is it creates a little variable for it, and it stores the address of the string in the variable. So for objects, it doesn't store the value in there. What it does is it stores the address of that object, meaning that it gets stored in a, and that address looks something like 0x527 or some gibberish to you. This means that it's all invisible to you and seems confusing, but that means you don't want to use double equals. What does that? So that was an explanation saying just don't use two equals to compare strings. So how do I compare two strings then? Well, here's how you would check if you the string is equal to done. If input dot equals done, the stuff I want to do. Okay. Also, y is not a val. Just mentioning that. The strings has a bunch of methods that we're going to use here. 2 lowercase, substring, and character at are what you need for this one. And string concatenation will help. So let's start by writing main with the to get you guys started. Public static void main. Right? Because I have no problem with going through most of this example for you, and then I'm going to leave these parts to you. Okay? So let's go ahead and go through these. All right. So we need a scanner because we're going to be taking in words from the user, right? Scanner.
Wait, do we input scanner before we do that?
I like to always let the IDE fix the imports for me. New scanner system. And so it's going to tell. You can call it keyboard. I like calling mine scanner. Okay, so system.in, and it says, and it went ahead and imported scanner for me automatically. Right? Import scanner if you need to. So we've got ourselves a scanner. And we also need an input for which we're going to read from the user. Okay? And this loop is going to continue while input dot, and remember, so we aren't using double equals done. This might not work, it said. Instead, for strings, we have to use input equals done. And this is actually, so in Python, it's actually kind of the reverse. With Python, you get when you use double equals, it checks for equality. But if you use the word is, it checks for the memory locations.
I think I was using dot equals with some earlier.
So while input dot equals done, or sorry, while input is not equal to done, we want this loop to continue, right? All right. So while this is not equal to done, okay, we want them to do. We want to read an input from the user. Input is equal to scanner dot next line, right? and then we want to convert it, right? We want to transform it. String, let's call it pigged, because it turned into pig Latin, right? Convert to pig Latin the input, right? Now notice that convert to pig Latin won't actually convert it into pig Latin yet, right?
Because we didn't tell it how to do that.
I didn't tell it how to do that, but I can still call it, right? Notice how I'm just organizing my code. I'm taking a big project and I've broken it down into smaller portions, and I'm working on like the flow of it, so that I've got that. So this is one strategy where you define what the parts are, and then you work on the individual parts. But no part is ever broken, right? The part might not work. It might not do its job, right? Convert to Big Latin isn't doing its job, but it isn't broken, right? You can always test your code, is the idea here. So string input. So while input is not equal to done, read a line, transform it, and then we will system.println pigged. And now this actually should do quite a bit for us. Okay, hello, and it prints back hello. Oh, I've got print, not print line, my bad.
Yeah.
See, even I make mistakes, but identify what they are. Hello, how are you? Done.
Yeah, I think there's a problem with my pig. It has an error on it.
That's
It says it cannot find the symbol.
pigged.
Yeah.
Did you call it string pigged? Are you?
I call it string pig.
Is it inside the while loop? Is the print line inside the while loop?
Yeah. Wait.
Right.
Yes, it's inside the while loop. It says it cannot find symbol method to convert pig language. I think it had a similar problem with my 3 digits.
Oh, it's because you've got convert to Big Latin over here, and you've got it with a lowercase t, right? Hey, I've made that mistake about a billion times. That's why I know to check for it as the first thing, right? So it's right. The difference. So here's one thing you need to understand. I come over and I fix your mistakes like that. The reason is not because I'm like inherently smart or anything. It's because I've already made that mistake 100 times, right? I've made it 100 times. I've corrected it for various students 500 times, right? So I'm really good at correcting mistakes because that's all I've been doing, right? You've made it your first time. It is extremely frustrating to correct your mistakes. Do not lose heart. Okay, so convert to Pig Latin, right? If we add, we can get it kind of close to working if we just simply add AY to the end, just like this, right now. Hello, and now it becomes hello A, and oofe, right? Or foo, it becomes fooe, but it's not working yet. So now your job is to make sure to fix convert to Pig Latin.
Yeah.
Now,
it's not letting me print. I must have forgotten.
I'll be around to help. That's fine. So now so these are the 2 functions you need to complete. So I suggest working on find the first val first, right? One last thing I forgot to do, right? My input, it said we needed to convert it to lowercase, so let's go ahead and do that. So input is equal to input dot to lowercase. That way you don't have to worry about that way when you're checking for vowels, you don't have to worry about uppercase A's and uppercase E's. All you have to do is worry about lowercase A's and lowercase E's, right? That makes sense to everybody? Okay, so now it's converted to lowercase. So we can convert it to Pig Latin. Okay, so again, work on find first val, which given a string should return the location of the first val. And then once you use that, you can use it to, you want to use that basically over here for something like this. Int first val index is equal to find first val word, right? So it uses this one to find the first. So it uses this method, right? This one calls this method, gets the number back from it, and stores it in here. And then it can use that. Well, once you know where the first val is, you know which rule of Pig Latin to use. All right, so let me go ahead and close this out. I'm going or stop recording. I'm going to upload this so you have it. So you have it as a reference, the PDF, I mean. And again, if you find yourself needing more stuff to work on for this, right over here, extra credit to do some basic encryption.